The reactions are elementary reactions and complex reactions. In that earlier we are discussed about that complex reactions. Complex reactions means the reaction if completed in multiple steps, it's called as complex reaction. The reaction mechanism will having the several steps are present. In those several steps, which step will having the slow step is called as rate determining step. The rate determining step is we are discussed in the complex reactions. In that complex reaction, in the rate determining step, participating number of molecules are called molecularity. Elementary reaction means if the reaction is completed in a single step, it's called as elementary reaction. If the reaction completed in single step, it's called as elementary reactions. In that condition, elementary condition, every independent factor is known as its order of reaction. For example, aqueous products, the order of reaction is 1. 2 aqueous products, the order of reaction is 2. Like that we have to identify. According to the order of reaction, the integration equation of the order of reaction for zero order reaction, in this zero order reaction, the integration equation is aqueous product in this condition, according to the rate equation, dx by dt is directly proportional to concentration of A. The concentration of the reactant concentration is 0. So it belongs to what about the zero order reaction. If removal of this proportionality sign, dx by dt is equal to Ka concentration. Now, here the concentration at T time, the concentration we are representing as A minus X. So, dx by dt is equal to Ka minus X. That X concentration is, reactant concentration is 0. So, that is the reason dx by dt is equal to what we are representing K. K means rate constant. To calculate the rate equation, here the rate of reaction versus K is there. K means rate constant. So this reaction is, we have to rearrange the equation. In this rearrangement, the time term, why we have to rearrange the equation? Because in the earlier we are discussed, reactants are converting as products at time is equal to 0. Reactant concentration is A, products concentration is 0. At time is equal to T, reactant concentration is A minus X and products concentration is X. At time is equal to infinite condition, reactant concentration is 0, products concentration is A. Means depend upon the time, the concentration is variable. So that is the reason here the relation in between concentration versus time relation is there. The relation in between concentration versus time. So due to this reason, the reaction is rearranged. So that is dx by dt is equal to K. We have to rearrange the equation. X belongs to concentration, T belongs to time. So this time factor, if you are moving this side, dx is equal to K into dt. Dx is equal to K into. This one is rearranged equation. Here the concentration is one side is present and time is another side. Now, this equation, if we are integrating, the concentration is integration in 0 to x limits and the time is 0 to t limits. So, the integration dx equation, here 0 to x limits and 0 to t limits, x is the concentration, here 0 to x limits, k is constant and t is time, that is 0 to t limits. Upper limit minus lower limit. Upper limit minus lower limit means x into x minus 0, is equal to k, upper limit minus lower limit t minus 0. So then x is equal to k into t, where k is equal to rate equation, where k is equal to x by t. This is zero order rate equation. This one belongs to zero order rate equation. Now units for zero order rate equation. Units, k is equal to x by t. K is equal to x by t, where x is equal to concentration. The concentration is representing as moles per liter. Moles per liter. And time, either you can take this reactions belongs to moderate reactions. Those moderate reactions are either seconds or hours or in case of minutes. So in this condition, if I am taking seconds in the time factor, so then k is equal to mole liter inverse second inverse. Mole liter inverse second inverse. This belongs to what about the zero order units. Zero order units and rate of reaction units both are same. Zero order units is k is equal to x by t moles liter. Rate of reaction means dx by dt. Moles liter and mole per liter and time. So these units and these units are both are equal. And generalized the units, generalized units for order of reaction. K is equal to liter n minus 1 mole 1 minus n time inverse. Liter n minus 1 mole 1 minus n time inverse. This one is what over the for any order of reaction we can identify. Here n is equal to order of reaction. N is equal to order of reaction. If you substitute here for zero order reaction, liter 0 minus 1 means liter inverse. Mole 1 minus n means 1 minus 0. So 1. Next again time inverse. Either you can use this equation for what about the generalizer for any order of reaction. The principle is liter n minus 1 mole 1 minus n time inverse. For this one is order of reaction. Here where n is equal to order of reaction. Now coming to the graph for zero order reaction. Here the graph is concentration versus time. Concentration versus time. The concentration is x versus time. According to the x versus time, k is equal to x by t. K is equal to x by t. So this one is zero order rate equation. X by t, x means concentration, t means time. So our relation is concentration versus time. So that is the reason if I am moving time factor here, so then x is equal to k into t. X is equal to k into t. So this graph belongs to y is equal to mx graph. Y is equal to mx. The graphs are two types. Y is equal to mx and y is equal to mx. Means through origin it will be takes place. That is called y is equal to mx. So this graph here on y axis we are taking concentration. The concentration is x, and x axis we are taking time. And this one is what about this rate. And m belongs to its slope, m is equal to k. So this belongs to what about the graph for zero order reaction. And another one, according to the graphical method of the zero order reaction, earlier the discussion in between the concentration versus time, at the same time the graphical method rate is independent of time for the zero order reaction. Rate is independent of time for zero order. Independent means it does not depend upon. So here the one graph belongs to on y-axis I am taking rate, x-axis taking time, rate is independent, so that is the reason it's a directly straight line. Or we can take vice versa is also time on y-axis and rate. If you are representing like this type of graph, that is independent of the reaction for rate in case of zero order reaction. Next, rate is independent of concentration of the reactant. Here the rate is independent of time and as well as rate is independent of concentration of the reactant, that is initial concentration of the reactant. In this condition, we are taking concentration on y-axis, that is reactant concentration is A, I am taking y-axis, and the rate I am taking x-axis. So it's an independent factor, so that is the reason it will get the straight line. Or vice versa, if you are taking what about the y-axis and x-axis condition, y-axis if you are taking rate and x-axis if we are taking concentration, that is independent concentration is there. And this is second type of for the representation of zero order reaction. Zero order reaction, another representation for reactant condition. Reactant condition means in the earlier graph is K is equal to X by T, and that in case of you are taking reactant condition, 0 representing in the zero order reaction for K is the constant. A means initial concentration of the reactant minus A minus X by T. So that we can representing our K is equal to X by T for the products condition. In case of reactant condition, if you are expressing the rate of reaction, A minus X by T. Because of how it will be means in the earlier discussion, reactant gives product, the initial concentration at time is equal to 0, A reactant concentration is A, products concentration is 0, and time equal to T condition A minus X, and this one is X and this one is 0 at infinite condition A. Like that, initial concentration is A, at T time that concentration is A minus X at given particular time T. So in this, the graph belongs to our concentration versus time. So due to that reason, concentration versus time, the reaction is what about the equation is we are rearranging, that is time factor if I am taking like this, K is equal K into T, A minus X. Concentration versus time, which concentration? Reactant concentration. So reactant concentration is A minus X. So A minus X is equal to this KT term if you are taking here minus K into T plus A. This graph belongs to what type of graph? Y is equal to minus mx plus c graph. So according to the Y is equal to minus mx plus c graph, here I am taking concentration on y-axis, time is on x-axis. Here the slope is what type of slope? Negative slope is there. So due to that reason it representing as negative slope. So due to that reason negative slope m is equal to minus k. K 0 indicates it's a zero order reaction. So for example, first order reaction for our convenient purpose we are representing 1, second order reaction 2, third order reaction 3. So for our convenience our zero order reaction is I am representing 0. The what type of slope we are getting for reaction condition is negative slope. A minus X I am representing is also ORR C. C indicating as concentration and A indicating as reactant initial concentration of the reactant. These are the graph representation for zero order reaction. And earlier representation is K is equal to X. So total 4 graphs are representing for the zero order reaction condition for explaining of the what about the representation according to the graphs. Next, zero order reaction half-life. Half-life of zero order reaction. In the name is also there half-life. Half-life means if we complete any reaction is 100%, that is called as 100% reaction is completed. If the reaction is completed only 50%, that 50% of the reaction is called half-life. So means if the reaction starts at 0 time, if it will be completed at 1 hour. The reaction starts at 0 time, it's completed as 1 hour. Then half-life of the life means half-life means the reactant concentration is converting as product. Half of the material, the required amount means 50% is required is the product and 50% is remaining in the reactant. So 50-50 is there, that is called half-life. That half-life means half of the time. How much time it will be takes place for zero order reaction half-life? The equation is we are representing here reactants converting as products. Reactant converting as product, time equal to 0 means the initial concentration condition, the initial reaction is called as time. That concentration of the reactant concentration A, on that time we are representing 0. Reaction not at all started, so products are 0. Next, time equal T. T time means reaction is started, and that condition reactant concentration is A minus X and products are X. And time equal T half. T half means the total reaction half of the time. On that condition, reactant concentration is A by 2 and products concentration is also A by 2. Reactant concentration is A by 2 and product is A by 2. A time is equal to infinite. Infinite means whatever the maximum time it will be, whatever the kept over on the reaction, then all reactants are converting products. When all reactant converting products means reactant is 0, products are A. Means on time continuation process, reactant concentration decreases, products concentration is increases. Now coming to our zero order reaction, the rate equation is K is equal to X by T. Zero order rate equation is K is equal to X by T. X belongs to concentration of the material and T belongs to time. K means rate constant. So if you are observing here, concentration is at half of the time, that we can representing as K is equal to half of the time means that we are representing A by 2. Means reactants half material is there, products is also half material. Reactants half material, products half material is there. In that half-life condition, K is equal to A by 2 by, on what time it will be? T half. So that we are representing T half. Now, the rearranged K is what we have to observe here. We can calculate the T half. Half-life we have to calculate. If you are taking this, K equal to A by 2 T half. Now, T half is equal to A by 2K. T half is equal to A by 2K. Means this belongs to whatever the half-life equation for zero order reaction. In this condition, if you are observing that A indicates as initial concentration. So therefore, T half is directly proportional to A. T half is directly proportional to A. A means initial concentration. So T half is directly proportional to A and the equation is T half is equal to A by 2K. This belongs to what about the zero order half-life equation. Half-life means half of the time it will be takes place, that is called zero order half-life equation. Generally the examples of this zero order rate equations are acetone and iodine equations. Means acetone reacts with iodine, it will be converting as how much time it will be takes place reaction with iodine. So these are the example for the reactions for zero order reaction. Next, some of the problems belongs to what about the zero order reaction. The problems belongs to zero order reaction problems are calculation of zero order reaction according to that rate equations and according to that half-life. For example, here the noted point is, important point is, half-life of zero order reaction is directly proportional to the initial concentration of the reactant. This is very noted point to calculation in the different type of problems. Now, according to that first problem, half-life of zero order reaction is 250 seconds. One problem is there. The problem is half-life of zero order reaction is 250 seconds. Half-life of zero order reaction is 250 seconds. What is the value of half-life? What is the value of half-life when initial concentration of the reactant increases 2 times? When initial concentration of the value increases 2 times. Once again I am repeating the problem. Half-life of zero order reaction is 250 seconds. What is the value of half-life when initial concentration of the reactant when initial concentration of the reactants increases 2 times. Here the condition is, our actual condition is, what about the T half is directly proportional to A. T half is directly proportional to A. So here initial concentration is increases how many times here? 2 times. Initial concentration means A we are increases 2 times. A increases 2 times. According to the equation, T half is directly proportional to A. Initial concentration increases 2 times. What is the time here? T half is equal to 250 seconds. T half is equal to, in the problem they are given in the 250 seconds. Therefore, the principle is T half is equal to 250 into 2. Why? T half is directly proportional to A. A increases 2 times. Obviously, the time is also increases 2 times. 250 into 2. So, thus T half is equal to 500 seconds. T half is equal to 500 seconds. So, this is according to half-life, we are calculating the zero order rate equation. So, this principle is also we can representing as the initial concentration and final concentration. If we are taking the principle x1 by T1 is equal to x2 by T2, also we can representing the condition. X1 means concentration of the reaction initial condition, T1 means half of the time, and x2 means another reaction, T2 means another time. If you are taking this principle is also we are taking the calculation of half-life conditions. Next, another problem if you are taking, half-life of zero order reaction is 250 seconds. Calculate the time for 75% of completion of reaction. Half-life of zero order reaction is 250 seconds. Half-life of zero order reaction is 250 seconds. Calculate time for 75% completion of reaction. In this condition, here percentage of reaction is given. See that carefully. Half-life of zero order reaction is 250 seconds. Calculate the time for 75% of completion of reaction is there. Here T half is equal to 250 seconds is there. When T half 250 seconds, then what about in this 250 seconds the concentration x1 is equal to 50. X1 is equal to 50 means reaction, half of the reaction means 50% is completed. Under condition, the T half condition is 250 seconds. And what we have to calculate? T2. In this T2 we have to calculate how much time and what percentage? X2, completion of X2 is how much percentage is completed? 75% is completed. According to the problem, zero order reaction 250 seconds, that is I am representing T half condition. T1 condition is 250, X1 condition is 50. In this condition 50% reaction is completed. If 75% completion of reaction, how much time it will be takes place? Our principle is X1 by T1 is equal to X2 by T2. So here x1 is equal to how much time it will be takes place? According to the equation, x1 by T1 is equal to x2 by T2. Here x1 is equal to 50, T1 is equal to 250, x2 means 75, T2 means we have to calculate. So T2 is equal to how we have to calculate? Means according to the cross multiplication, T2 is equal x2 into T1 by x1. T2 is equal to x2 into T1 by x1. x2 into T1 by x1. So x2 is how much? x2 T2 is equal to x2 belongs to here 75 into T1 it will be 250. Next x1 means here 50. So the total answer T2 is equal 75 into 250 into 25. 75 into 250 by 15, that will belongs to 375. That answer is 375. 375 seconds we are getting. So this is what about the method of the calculation. Another direct principle is also there. The direct principle means 75% completion of reaction. T 75% completion of reaction. The direct principle is 3 by 2 T half. 3 by 2 T half. This is direct principle for calculation of zero order reaction for 75%. So here T 75% is equal to 3 by 2. 75% means 3 by 2. Here in the problem, what is the given? 250. 3 by 2 into 250. Then T 75, you are getting the answer. So this one belongs to direct principle for the entrance purpose. Rate equation for first order reaction. Rate equation for first order reaction. A gives products. A gives products. This is the reaction. In this condition, rate of reaction dx by dt is directly proportional to concentration of A. If for removal of this proportionality sign, dx by dt is equal to k into A. At T time the concentration is, at T time the concentration we are representing dx by dt is equal to k into A minus x. Here the equation is rate of reaction versus concentration is there. Here the equation is rate of reaction versus concentration. Now we have to rearrange the equation to identify what about the rate constant. The reaction is rearranged by concentration versus time. Means all concentration terms are one side and time terms are another side. So dx by dt is equal to k into A minus x. All concentration terms are one side. Means here dx by A minus x is equal to k into dt. Now in this condition, concentration terms are one side and time terms are another side. Both sides are there. Now this equation is integration in between 0 to x limits for concentration and time is 0 to t limits. Now the integration dx by A minus x 0 to x limits, concentration, k is the constant, and dt time, the time is integrated in between 0 to time limits. The integral equation minus natural log A minus x 0 to x limits, k and 0 to t limits. Upper limit minus lower limit minus natural log A minus x minus natural log A is equal to k into t minus 0. So minus natural log A minus x plus natural log A k into t. If this equation is minus b plus a form is there, if I am representing a minus b form, natural log a minus natural log a minus x is equal to k into t. This one natural log a by a minus x is equal to k into t. We have to identify the k, so that is the reason k is equal to 1 by t natural log a by a minus x. So this belongs to what about this natural log equation. If you are taking what about the logarithm value for this condition, logarithm base 10 is equal to k equal to 2.303 by t log a by a minus x. This one is zero order rate equation. This belongs to zero order. If you are taking direct reaction here, that k natural log a by a minus equal k into t, according to that k equal to logarithm value based on value k equal 2.303 by t log a by a minus x. A means initial concentration, a minus x means at the given time concentration, and t means either seconds or hours it will be takes place. This I am representing, I am k1. K1 belongs to first order reaction. So here units. According to the units, if you are observed that K1 is equal to generalized equation is liter n minus 1 mole 1 minus n time inverse. Here K1 is equal to, where n is equal to what is that? Order of reaction. N is equal to order of reaction. Here the order of reaction is first order. 1 minus 1, it's 0. Mole. Again 1 minus 1, 0. Then our rate equation is time inverse. 0 order rate equation is time inverse. Time inverse means either you can write second inverse, or you can write minute inverse, or you can write hours inverse. So this one is units for 0 order reaction. What about the generalized equation method? In case of another method for calculating the units for 0 order reaction is dx by dt is equal to k into a minus x. K is equal to dx by dt into 1 by a minus x. Here where x is equal to concentration, x belongs to concentration. What is the concentration units? That is mole liter inverse. And this time belongs to either seconds or minute. I am representing here seconds into 1 by a minus x. Again a minus x is also representing the concentration. The concentration is mole liter inverse. So mole liter inverse cancel. Now k is equal to 1 by second. K equal to 1 by second, that is time. Now we can represent k is equal to second inverse. This one is what about the first order units. First order units are time inverse. Time inverse means either second inverse or minute inverse, whatever it may be. Now graphical representations for first order reaction. So graphical means every order of reaction, that parts are majorly what about this rate equation, and according to the rate equation we are representing the graph. For first order rate equation, k is equal to 2.303 by t log a by a minus x. This is first order rate equation. Earlier we are discussing about that 0 order reaction rate equation is k is equal to x by t. Now according to the first order equation, the concentration versus time. Now concentration versus, what is the concentration? A minus x versus time graph. Now we are identifying the graph is a minus x versus time. Time means depend upon the problematic part, either seconds or minutes or hours. Now here a minus x versus time. Now rate of equation for 0 order reaction is 2.303 by t log a by a minus x is equal to k. Mean that is k equal 2.303 by t log a by a minus x. Now our relation in between a minus x versus time. So we have to change the equation. Now this 2.303 t part if you are taking here, then log a by a minus x is equal to k into t by 2.303. If we expand this equation, log a minus log a minus x is equal to k into t by 2.303. Now our relation is a minus x versus time is required. So need not necessary about log a. If you are taking here, then plus log a is converting as minus log a. Minus log a minus x is equal to k into t by 2.303 minus log a. Both say, because of e required a minus x versus time, so multiply the entire equation with negative charge. So minus into minus plus, so that is the reason log A minus x is equal to minus k into t by 2.303 plus log A. Now this relation is, what about the A minus x versus time relation is there. This relation according to the graph equation is y is equal to minus mx plus c. This representing graph is y is equal to minus mx plus c. Here the slope is, what type of slope is required here obtained is negative slope is obtained. So the graphical representation is, on y-axis we are taking concentration. The concentration is log A minus x. On x-axis we are taking time. The slope is, what type of slope we are getting here? Negative slope. So here the slope is m. M is equal to minus k by 2.303. The intercept c is equal to log A. This graph belongs to, what about the first order rate equation graph? What type of slope we are getting? Log A minus x versus time graph is negative slope. If you are taking 2.30 means log A by A minus x versus concentration graph. The second graph is log A by A minus x versus time. Second graph is log A by A minus x versus time. In this condition, the rate equation of first order reaction is 2.303 by t log A by A minus x is equal to k. Now our relation is log A by A minus x versus time. So we have to rearrange the equation. Log A by A minus x is equal to k into t by 2.303. This graph obtained is y is equal to mx graph. Y is equal to mx. According to the y is equal to mx graph, here x-axis we are taking time, y-axis we are taking log A by A minus x. Through origin we are getting the plot. The slope is m is equal to k by 2.303. This graph belongs to second representation, log A by A minus x versus time. This earlier graph is log A minus x versus time, and this one is. Next, third type of graph is concentration versus time we are representing. Another one is rate of reaction versus time. The third type of graph is rate versus time. So rate versus time and rate versus concentration, rate versus representation, rate versus time. Another one is rate versus concentration. Here the rate versus concentration means dx by dt is equal to k into A minus x. This one is rate of reaction and this one is concentration. This belongs to what type of? Y is equal to mx. According to this, here rate dx by dt, the concentration we are representing either A minus x, or in case of representing C, or in case of representing A. Through origin it will be takes place. That is equal to m is equal to k. So this is third type of graph representation, rate of reaction versus concentration. Next, another one is half-life. First order reaction half-life, here reactants converting as products. Reactant converting as product, time is equal to 0. At 0 time reactants is A, products is 0. Time equal to T. Reactant concentration A minus X, products concentration is X. Time equal to T half, reactant concentration is A by 2, products concentration is A by 2. Time equal to infinite, 0 and A. The first order rate equation is k equal to 2.303 by t log a by a minus x. A means initial concentration, a minus x means at a given time the concentration. Now we are calculating the half-life for what about the half of the time condition. Then the equation is k equal to 2.303 by t half log a is initial concentration, a minus x means at t half condition. What about this t half condition? The concentration is a by 2. Now k equal to 2.303 t half log a into 2 by a. Now k equal to 2.303 t half log 2. Log 2 value is 0.3010. 2.303 by t half. Log 2 value is 0.3010. If you are multiply 2.303 into 0.3010, then k is equal to 0.693 by t half. Now t half is equal to 0.693 by k. This one is what about the first order half-life equation. First order half-life equation is t half is equal to 0.693 by k. The first order equation is general examples are cyclopropane dissociation. Cyclopropane dissociation means cyclopropane is converting as cyclopropene. This one is cyclopropane converting as propene. First order. And hydrolysis of methyl acetate is also example for first order equation. Hydrolysis of methyl acetate. Hydrolysis of methyl acetate is also next. Chloroacetanilide is all converted to parachloroacetanilide is also example for first order equation. Chloroacetanilide is converted to parachloro. Chloroacetanilide is converted to parachloroacetanilide is also belongs to what about this first order equation. Based on this first order equation, again the half-life equation problems are there. That half-life equation problems representation. Here t half is equal to 0.693 by k. Half-life of first order reaction is independent of the initial concentration of the reactants. Independent of initial concentration of the reactant condition is there. And for first order reaction independent of initial concentration means, for example, if reactant concentration is 100, it converting as 50. If it converting as 25, if it converting as 12.5. In this condition, 100 to 50 the time is t. Next, half-life of first order reaction is independent of initial concentration is there. So due to that reason, independent means 100 to 50 if t time is there. 50 to 25 is also again t time. 25 to 12.5 is also t time. 12.5 to 6.25 is also t time. For example, here 5 minutes is there. Here also 5 minutes. Here also 5 minutes. All are 5 minutes. Because of the half-life of first order reaction is independent of initial concentration of the reactant condition. Based on that thing, we have to given the based on the thing we have to given in the consolidated table. Based on the consolidated table, we have to calculate different type of problems. To calculate the half-life of first order reaction, the generalized table is here. This one is number of t halves and this one is a minus x and x. A minus x means after the completion of the reaction is how much amount is left over. X is how much amount of material is consumed and it will be converting as a product. Here the number of t halves means we can calculate the direct principal steps. Number of t halves, first half, second half, third half, fourth half, fifth half, and as just infinite condition. That is 10 halves. So number of t halves, based on the number of t halves, If reaction is completed 50%, then we can representing as 1 by 2, and the product is also completed as 50%, that is 1 by 2. So that is also we can representing as initial 1 minus 1 by 2. Next, in case of second time half of the material is confirmed, means number of T halves are 2. If 2 times are converted as initial concentration, that 50% is converted to 25%, means overall reaction is, that is 75%. Overall reaction, how much product it will be converted, means 75%, this one is 25%. So here that we can representing as 1 by 4, this we can also representing 1 by 2 to the power of 2. So the 75% of the reaction representing as 3 by 4. 50% representing reaction is 1 by 2, 75% is 3 by 4. That we can representing again 1 minus 1 by 2 to the power of 2. If the number of T halves are 3, this one is first half is completed, is 50%, second half completion means 25%, that is left over. Third half completion, the leftover material is 12.5% is there. The consumed material is 87.5% is consumed material. So 12.5% means that you can representing as 1 by 8 or 1 by 2 to the power 3. 87.5% means 7 by 8 and this. And the number of T halves are 4 times or half of the material. The leftover material is 6.25% is leftover from the initial, and that what we are getting the final product is 93.75%, 6.25 representing 1 by 16, 1 by 2 to the power of 4, 15 by 16. Next, number of T halves are 5 times or half of the material, then the percentage is 3.125, that is 1 by 32. Next, the product is 96.875% is there. Like this, number of T halves are continuation at the 10th time approximately equal, that is leftover material is 0.1 and approximately completed material is 99.9. So this is direct technique for how many T halves are there and how much percentage is completed for the calculation of half-life. So number of T halves, 1 half 50%, 2 halves 25%, 3 halves 12.5%, 4 halves 6.25% is leftover material, and consumed materials are for 1 half 50%, 2 halves 75%, 3 halves 87.5%, 4 halves 93.75%, and 5 halves is 96%, and 10 halves means 99.99%. So in the half-life calculation, they given the problem, half-life problem, how many T halves, for example, if a reaction is completed 75%, how many T halves it will be takes place. If the reaction is completed 87.5% is completed, how many T halves it will take. So in case of, so 3 halves are the 3 half means half-life is 3 times is there, and what about the product percentage? Like this they are asking the problems. Based on that problem, this consolidated table is required.